Hello students, last time we have discussed about isomerism. Now we are going to study alkanes in details. Alkanes have a general formula CnH2n plus 2. They are saturated hydrocarbons. We have two examples, methane and ethane. Methane is otherwise called marsh gas as it is obtained from marshy places. It's also called fire damp because methane gas can burn over water. And the second one is ethane. So two examples. First, let us see how they are prepared in the lab. General methods and laboratory method. The general method is methane and ethane can be prepared by reduction of alkyl halides by zinc copper coupled and alcohol. Example, methyl iodide reduced hydrogen, nascent hydrogen is used, zinc copper coupled and alcohol. When heated, they produce nascent hydrogen, you get methane and hydrogen iodide. So this is how methane is prepared. Same way ethane can be obtained from ethyl bromide. CH3CH2Br plus nascent hydrogen obtained from zinc copper coupled and alcohol, they react giving hydrogen, so you get ethane and hydrogen bromide. So this is a general method. Zinc copper coupled is a combination of two metals. It is blended with alcohol, so the reaction takes place and hydrogen is evolved. That hydrogen will reduce the alkyl halide to give the alkane. Okay. Now the next one is the nascent hydrogen obtained. Nascent means atomic form of hydrogen, which is just bond, is the reaction mixture between zinc, copper and ethanol. Okay. Now methane and ethane are gases. They are collected by downward displacement of water. This is a general information. Then the laboratory method, how do we prepare it in the laboratory? In the laboratory, methane is prepared by the action of heat on a mixture of sodium acetate and soda lime. This will give methane. Ethane is obtained by action of heat on the mixture of sodium propanoate and soda lime. Propionate and propanoate, they are same, right? And what is soda lime? Soda lime is a mixture of caustic soda, that is NaOH, and quicklime. Now here actually sodium hydroxide is reacting. Quicklime is there in the medium to absorb moisture to keep the reaction dry. Okay. Sodium acetate has the formula CH3COO Na and caustic soda is NaOH. So the reaction, this part is being removed as Na2CO3 and the remaining CH3 and this hydrogen is CH4. So methane is obtained like this. Same way, sodium propanoate, if you take CH3CH2, one more methyl group is here, CH3CH2 COONA plus NaOH, quicklime is there, that is calcium oxide. The mixture of quicklime and caustic soda is called soda lime, that is NaOH and calcium oxide. So here again this portion is removed, so you get CH4 and CH3CH3. Okay, so this part, not this one. So this will be Na2CO3 and CH3CH3. So ethane is obtained. Both methane and ethane are colorless, odorless gases. Okay. So preparation is done. Now reactions of methane and ethane. We know methane and ethane are saturated hydrocarbons. Any hydrocarbon can burn. Okay. So they are combustible. Burning in air, limited supply of air and free supply of air. When the air supply is limited, carbon monoxide and water vapor are produced. Any hydrocarbon, okay? And when there is abundant supply of air, free supply of air, you get carbon dioxide and water vapor. So you have to write CH4 plus O2 gives CO plus H2O and then balance the reaction. So you have the reaction. Same way ethane C2H6 plus O2, CO plus H2O is the product because limited supply of air. Again balance it. In the free supply of air, product will be carbon dioxide and water vapor. So methane will give 2O2 is required, CO2 and H2O. Ethane will also give CO2 and H2O. So this is common to all organic compounds. Okay. So free supply of air and limited supply. Remember, in free supply you have carbon dioxide and water vapor. In limited supply you have carbon monoxide and water vapor. And then balance the equation. Okay. Now let us see the other reactions. Substitution reaction. As I have already mentioned, methane and ethane both are saturated hydrocarbons. So they undergo substitution reaction. What is substitution reaction? Replacement of one or more hydrogen atoms of the alkane. Example, methane. There are 4 hydrogen atoms. Okay. So you remove one hydrogen and put something else in its place. That is called a substitution. Then you can remove the second one, third one. Like that you can remove all of them one after the other by some other atom or group. So that is called a substitution reaction. Now here we have the example is halogenation. Halogenation means substitution by halogen, reaction with halogen. Now the example I am taking is chlorine. So it is halogenation and also it is chlorination. If you use bromine, bromination. If you use iodine, iodination and so on. Okay. So chlorination of methane and ethane takes place in the presence of diffuse sunlight. This is a point to be noted. Diffuse sunlight. Why? Light energy helps the chlorine molecule to split into chlorine atoms. We need light energy. Now if you use direct sunlight, what will happen? The reaction will be violent and explosive. Okay. And if you use no light, absence of light, the reaction is negligible. So there has to be diffused sunlight so that the reaction takes place at moderate rates. Now let's have the reaction. Methane plus Cl2. You see there are 4 hydrogen atoms. One is removed. One chlorine. Okay. And one hydrogen, HCl, the chlorine will go to the place of hydrogen. So CH3Cl, one chlorine has come to the place of hydrogen. So one hydrogen less. So methane, it is called methyl chloride or monochloromethane. Next one, this methyl chloride again reacts with chlorine. One more hydrogen goes. So HCl is again formed and CH2Cl2, chlorine increases, hydrogen decreases. Methylene dichloride or dichloromethane. Then take that methylene dichloride, again reacts with chlorine, diffuse sunlight. One more hydrogen goes and chlorine comes in. So CHCl3 and HCl. This is called chloroform or trichloromethane. Then we have the fourth one, chloroform. You can bring this side and again react with chlorine. The last hydrogen, one more hydrogen is there, that goes out. HCl is formed and CCl4, carbon tetrachloride. IUPAC name is tetrachloroethane. This is one chlorine at a time, one hydrogen replaced at a time. Now if you want to add up all these reactions, excess of chlorine is taken, you will get CH4 plus 4Cl2, CCl4 plus 4HCl. So according to the question you may answer. When chlorine, methane reacts with excess of chlorine, CCl4 is formed. Methane reacts with 1 mole of chlorine, methyl chloride is formed. Methyl chloride again changed to methylene dichloride, then chloroform and carbon tetrachloride. Hope you are understanding. Now let us take ethane. How does ethane react? Ethane reacts with chlorine the same way. C2H6. One hydrogen goes out, one chlorine comes in. C2H5, Cl and HCl. So monochloroethane. Now take monochloroethane this side, chlorine reacts, again one more hydrogen goes, C2H4Cl2 and HCl. You are understanding? One hydrogen goes out, one chlorine comes in, okay? Because this Cl2 splits as 2 chlorine atoms. One will take a hydrogen and form HCl. The other chlorine will combine or take the place of the hydrogen which has left, okay? So you have the trichloroethane, then it will become tetrachloroethane, and then you have pentachloroethane and hexachloroethane. Last, until all the hydrogens are removed, one after the other, they will all be removed. Now you may add up and get a combined reaction also. That is about the reactions of methane and ethane, substitution reaction. Now uses of methane. Methane is used as an illuminant in hawker's lamp. What is illuminant? You must have seen the vendors who sell this peanuts and vegetables and all. They carry a kind of lamp, a small cylinder, and a bulb-like thing glows on top of it. That is called the hawker's lamp, where we use, methane or ethane can be used. And methane is also used as a fuel in the form of CNG, compressed natural gas, PNG, piped natural gas coming to home as a fuel in automobiles and industries. Then for the preparation of compounds such as methanol, formaldehyde, chloroform, carbon tetrachloride, all this methane is required. It's a very useful compound. Then uses of ethane. Ethane also can be used as a fuel, burns and produces high amount of energy. Preparation of compounds like ethanol, acetaldehyde and acetic acid. So that's it about alkanes, the detailed study of alkanes. Children, watch it again and again. If you have query, please write in the comment section and you may subscribe. Thank you for watching.